Hi guys. Okay, this is Unit 11 Day 6, and I don't want to take up too much of your time with this lesson, so I'll give you a quick shortcut in case you don't want to watch the entire video. Totally understandable. But if it's not making sense, I encourage you to watch the entire video. So I'll give you a quick little piece at the beginning, and I think that should be enough for you if you've been watching the videos up until now and you understand your homework. Okay, so the very first thing is there's this picture that's down below here of a box plot. That's what we're learning about today. Your learning target is I can compare box plots to draw conclusions. So you just have to be able to understand how to read a box plot. All right, so we've already talked about these terms before, so it's a little bit of a review, plus you're learning about box plots. All right, the very first thing, the smallest piece of data in something is always called the minimum. I guess I should fill in the beginning first. But the minimum is going to be the smallest piece of data, and the maximum is always going to be the largest piece of data. We also call those the whiskers on your box plot. I'll go back up and fill in the very first space. So a box plot displays a data distribution using 5 key numbers. You're going to see all of those elements down below. The difference between the first and third quartile range is called the interquartile range, and we've learned that word before. We also call that the IQR, if you don't want to spell all that out, the interquartile range. So we're going to take these 5 pieces of data that we're learning about, or we have learned about them already, and we're going to make this box plot below. All right, so the next thing, and let me switch colors here. The next thing is the median of the lower half of the data. We call that the first quartile. So I'm just going to say quartile 1, or the first quartile. And on your box plot, that's going to be the first line of your box. The next thing, let's switch colors again. The next thing is the median of the upper half of the data. We call that the third quartile. You probably remember that from your last assignment, or quartile 3. That's going to be the last part of your box right here. And then the median of the data. So median means middle. The very center piece of your data, we just call that the median. We're going to represent that by this middle line in our box plot. All right, so once you get those 3 lines, all you're going to do is now draw a box around your data, around your 3 lines like that, and then you connect them. These are called the whiskers, so you just draw it out like that and draw your other line out to there. As long as you understand that, you're going to get today's homework just fine. If you still need a little bit more guidance, keep watching and we'll go over the next problem. So our question says, use the data below to create a 5-number summary and sketch a box plot. So question 1, the following data set represents the number of animal crackers in the snack size box. Very first step, before I can even start drawing my box plot, is I need to list out my numbers from least to greatest. So I'm going to say, it looks like 34, 45, 47, there's 2 48s, 49, and 50. Okay, so very first step, let's find the middle piece of data, and I'm going to go ahead and switch colors over here. It looks like I have 3 on each side. If I say 48 is my middle, is 48 my median? Yes, it is, because it's right in the middle. So let's put 48 in for the median. Now I need to find the minimum and the maximum numbers. My minimum number is going to be the one on the far left, and my maximum is the one on the far right. So our minimum number is 34, or our lowest number, and our highest or our maximum number is 50. Now I need to find the first quartile and the third quartile, and in order to do that, I'm just going to take the first half of the data and find the number that's in between. So in between 34, 45, and 47, what number is right in the middle? It looks like 45. So 45 is going to be my first quartile. And on my second half of the data, in between 48 and 50, it looks like 49 is right in the middle. So 49 is going to be my third quartile. Now let's go ahead and make our box and whisker plot. And I hope you don't mind, I'm going to erase just a little bit around here. Darn, it won't, unless I delete the whole thing. I don't want to do that. All right, let's go ahead and just use a different color here. First step, let's go ahead and write our median. Our median, if you notice right here, was 48. So I'm going to locate that somewhere on my number line down below, and it's okay to estimate because they're not very clearly labeled. Next one, my third quartile. That is this number right here, 49. So I'm going to say 49 is really close to 48. Our first quartile, it looks like, is 45. So I'm going to say 45 is right here. Now that I have my 3 lines, I can connect them to make a box. All that's left are the whiskers. And in order to do that, you have to find the minimum number, which is 34. So I'm going to draw a line all the way out to 34. And my maximum number is 50, so my line goes out to 50. And that is how you draw your box and whisker plot, or your box plot. Okay, so question number 2. The following data set represents the number of hours a small candle will burn. And I'm going to just list these from least to greatest. Here I go. Looks like our smallest number is 7. And I'm going to try and leave room for all my numbers here. 8, 9, I have another 9, 10, 11, 11, 12, 14, 15, 15, 16, and 19. Okay, that looks pretty good. If I had to pick the number in the middle, I could count all of these. Do what you need. I'm going to start counting. Let's see what I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means I'll have 6 numbers on each side. So the 7th number is going to be right in the middle. So my median is going to be 11. That also means, since my median's 11, I can put that on my box plot down below. Okay, next one. Let's find the minimum number and the maximum number. My minimum number is 7. My max number is 19. Sorry if you can't really see over here. It said minimum right there. So I'm going to say minimum is 11. And our max number is 19. We got to find the first quartile. So to do that, let's take our first half of the data. So from 11 all the way down to 7. And I need to find the first half of the data, or the average, or what do we call that? The median. What number is right in the middle? It looks like I actually have 2 numbers that are right in the middle. So we have to take the average of those numbers. What that means is you add them together and then divide by however many numbers you have. So I would add 9 plus 9, and then I have to divide that by however many numbers are in that, and there's 2. That gives me 9. All that's telling me is my median of the first half of my data, or my first quartile, is going to be 9. Oh no, I made a mistake over here. I see it now. My minimum number wasn't 11, it was 7. Okay, so my first quartile is 9. Let's figure out what my second quartile is going to be. That's from 14 all the way up until 19. Ooh, what do I have in the middle? Oh, no, sorry. That goes from 12 all the way up to 19. Sorry, this can get kind of hard to read if I'm working in such a small space. I'll switch colors again. I'm going all the way up from 12 up to 19. That is just my second half of my data. Because if you take a look here, the very center of the data was 11. I think that really helps if I switch colors. I'll try and be better about that. But this program is really tricky about switching colors. Okay, so looking from 12 all the way up to 19, which numbers are in the middle? I can see here that there's 2 numbers that are in the middle. And it is 15 and 15. and the average of that is going to be 15. So my third quartile is going to be 15. So I can start marking right now. My first quartile was 9. My third quartile was 15. Now that I have my 3 lines, I can go ahead and make a box plot. The minimum number was 7. Let's go down to 7. And my maximum number was 19. So let's go up to 19. All right, now I know that this picture isn't perfect, but it's close enough. It'll do. We kind of have to estimate because the numbers aren't exact on our number lines. All right, question number 3. Use the given box plot to determine the 5-number summary. All right, so this one's going to be awesome because now we just look at this box plot that's over here, and we have to determine what our 5 numbers are going to be. So it looks like my median is always that number that's right in the middle of the box plot, that middle line. So my median is going to be 14. My third quartile is going to be the last line in the box, and it looks like my third quartile is going to be 16. My first quartile down here is going to be the first line in the box, and it looks like that number is going to be 12. So if I had to find my minimum number, it goes all the way down here to 11, and my maximum number, I'm just going to have to read this. It looks like it goes up to 18. And that's it. I have now filled in my 5 numbers that I need in my box plot. Okay, next question. This one says, use your knowledge of box plots to answer the questions below. So we see 2 box plots and then this paragraph. Evan conducts an exit poll at the public library, and he wants to compare the ages of voters who voted Republican to those who voted Democrat. He thinks that there will be a greater variability of ages. That means he thinks the ages are going to be more spread out in the voters who voted Democrat than those who voted Republican. So he thinks that those who voted Democrat, their ages are going to be more spread out than those who voted down here Republican. Let's go ahead and find out if he's right by taking a look at our box plot. So question 4 says, what is the difference in measure of center of the voters who voted Republican and Democrat? Okay, first of all, difference means subtract. Let's find the difference. Let's subtract the greatest number from the smallest. The greatest number, take away the smallest number. The next thing, measure of center, this word means the median. Let's go ahead and figure out what the medians are going to be and then subtract them and figure out what the measure of center is. So our median right here, ooh, this one's kind of close. It looks like it could be 49. So Republican median, I'm going to say is 49. Democrat median, I'm going to say is probably 35. Looking down here. Oh, maybe 36. I'm going to say 36. And we just subtract them. And I got 13. So the difference in measure of center of the voters who voted Republican and Democrat is 13. And I think that's going to be years. Let me flip over my page to my notes. Yeah, it's going to be measured in years. So they're saying in age, right? The median age for people who voted Democrat was about 36, and the median age for people who voted Republican was about 49 or 50, and so the difference in years of people was about 13 years. And I'm actually going to put about because I could have read this different than you did because these numbers are not exact right here. Question 5 says, determine the variability, so that means how spread out. I'll write right here, how spread out. Determine how spread out the voters who voted Republican are. So they're saying right here, we're looking at our end pieces, and we're going to see how spread out their ages are. And then determine the variability of voters who voted Democrat. So we're going to take the interquartile ranges and subtract them to figure out how spread out the Democrats are. Here we go. I'm going to start by changing colors because I think that will help a lot. So it looks like here we have 60, take away 40. And 60 minus 40 gives us 20. So the variability of voters who voted Republican was about 20 years. They were spread out by about 20 years. And I'll put Republican next to that. All right, how spread out were the Democrats? What was their variability here? Let's take the highest number. I'm going to say that's 42. Yeah, let's say 42. And let's subtract the smallest number. I'm going to say that's 28. But once again, I could be getting different numbers than you. So let me do a little subtraction here. 12 minus 8 gives us 4. And 3 minus 2 gives us 1. So the variability for the Democratic side would be about 14 years. Okay, awesome. So how is the difference in centers related to the variability of each party? Well, to begin, let's go back to the question because it said Evan conducted this experiment and he was comparing the Democrats, like the ages of voters between Democrats and Republicans, and he thinks that there will be a greater variability of ages in the voters who voted Democrat than those who voted Republican. So he's thinking that the Democrat side right here is going to be more spread out and have more years in between them. But when we went down here below, for the Democrat side, we got 14 years was their variability. So how is the difference in centers related to the variability of each party? So the difference of centers was up here. And we put it's about 13 years. For Democrats, we got 14 years. So I would have to say that the difference of centers, and I'll write this out as we go, the difference of centers is approximately equal to the variability in the Democrat voters. Also, it looks like up here, Evan was wrong because the variability in Republicans was a lot higher than that in the Democrat Party. Okay, so use your knowledge of box plots to answer the questions below. We are on our very last portion, and this is the last thing you'll be learning for the year. Then after this is just a review and you're done. So it's also, while we're here talking about this, it's also really important that you know that we are here as your teachers to help you get caught up and make sure that you understand what you're doing. So if you get behind, please just reach out to us because that's what we're here for. We're here to help you. All right, use your knowledge of the box plots. Let's answer the questions below. So it looks like we have two states, Florida and Texas, and we are talking about minutes on American Ninja Warrior course. Ooh. So the question says, what was the median time for both courses? So the median time for Florida is going to be this middle line right here, which is about 10. Is this in minutes? Yeah, 10 minutes. So I'm going to say Florida, their median time, 10 minutes. And Texas, their median time right here, if I were to just go down, what do we think that's going to be? I'm going to say 12 minutes. So median time for Texas, 12 minutes. Which course appears to be more difficult and why? Well, if you look at our box plot right here, it looks like Texas appears to be more difficult because it has a wider spread. And 50% of the data was above Florida's median. So it looks like it's taking Texas longer to finish the course. So I'm going to say Texas, and instead of writing out why, you can replay what I just barely said. Texas appears to be more difficult because it had a wider spread. So see how spread out they are from their first quartile to their third quartile? It looks like it's just taking them a lot longer to finish. and their median is above Florida's, and 50% of the data is above Florida's median. So that's pretty crazy. Question 9. A participant finished in 14 minutes in Texas. What can you conclude about the participant? 14 minutes, that's about right here, if I had to guess. So what we can guess, or what we can conclude about that participant, was that they finished in the third quartile, slightly above the median. They finished in the third quartile, slightly above the median. Okay, so that is it for today's lesson. If you have any questions at all, please just reach out. We're here to help. You guys are great. Thanks.